Okay, so we also had a question on 2225. 2225 is a synthesis problem where we have the initial starting material set out and then the conditions between each of the places. The first set of conditions is the conditions for bromination of an aromatic, and so we see that Br2 and FeBr3 together work to install bromine any position on the ring since they're all equivalent. Remember, the Br2 is not a good electrophile on its own, but the FeBr3 makes a positive charge bromine that can then react with the ring. After we have an alkyl halide, or an aryl halide, in this case an aromatic halide, we can react it with a magnesium, metallic magnesium, to make the Grignard reagent. The Grignard reagent is able to open up an epoxide. Epoxides and carbonyls are the main things that Grignards react with. When it opens up the epoxide, we'll end up with these two carbons of the epoxide installed onto the ring, and the O, which gets trapped as an OH after we add or work up an acid. Once we have this alcohol, we're doing two different things to it. First, we're converting it to an aldehyde with PCC. That converts the C product to the D product, so the alcohol just gets oxidized up one step. PCC is pyridinium chlorochromate, which doesn't allow the alcohol or the aldehyde to form the diol, and so only will create the aldehyde. And then the PBr3 reacts with the alcohol to create the bromine instead, replacing the alcohol with a bromine through an SN2 reaction. That bromine can be converted to the triphenylphosphine derivative, the Wittig reagent, by reacting with triphenylphosphine and then with a strong base like N-butyl lithium. Once we have the aldehyde and the Wittig reagent, we can react those together to make an alkene. I only drew the cis form of the alkene here, but both cis and trans are possible.